All right, so our first unit is all about basic geometry. So we're going to start out with some definitions. Now, I want you to put these on your index cards. Now, when you make your index card on the front, you typically put the term and then a picture. And then on the back, that's where you will put your definition. So on the front, you put point. Now, what does a point look like? A dot. Good. So on the front of your index card, put a point with a dot, and then on the back, indicates a location and has no size. Now, because I only gave you 6 index cards, you probably want to put these 3 things on the same index card. Okay? Sorry, I know I just mentioned that. Some of you were already writing. But I think these are pretty quick definitions that you could put them all 3 on the same card. Now, line is another one. Does anybody know what a line looks like? Pretty much straight, but it has arrows on both ends. So on the front of your index card, write line and put that line with arrows on both ends. Okay? It has to have arrows on both ends. If not, it's considered something different. And that's like the definition. A line extends without end in opposite directions. It doesn't have a thickness, but it contains an infinitely many points. So an infinite amount of points. So really, if you put a bunch of dots together, it makes a line. But lines keep going on forever and ever and ever. So when you graph lines in math too, you probably thought about the equation y equals mx plus b. It's already instilled into your brains. And you put arrows on both sides when you graphed it because it keeps going on forever because it has that constant rate of change and constant slope. So that's what lines are. Now, planes are different. They're not airplanes that fly in the sky, but planes are like sheets of paper. So if you want to kind of draw a box there. But planes actually extend on typically forever in all directions. Planes are kind of hard to talk about. They're a flat surface that extends without end. Again, no thickness, and it contains an infinite amount of lines. And I did not spell infinitely right on this one. So the old program that we used to use used to like underline the word saying, oops, you spelled it wrong. But this new program does not do that. So you may notice that I spell a lot of things wrong because, again, math teacher. When I think about a plane, I a lot of times think about a piece of paper, but you can also think about the walls like in the room. They're all planes. The ceiling, the floor, these 4 walls are all rooms. But imagine you have a piece of paper and it just extends everywhere and keeps going. It's a flat surface. On your notebook paper, to kind of keep things kind of consistent, you could write point, line, plane, and then write to the side 3 index cards. So that way you know that was part of these notes, were those 3 definitions. Now, I'm not going to ask you questions like this on like your quiz or test. I'm not going to say, what is the definition of a point? So you don't have to memorize that, but you do have to like know what it is. So a point is a dot. A line it's straight with arrows on both sides. A plane is like a piece of paper. Keeps going all directions. A flat surface. Just a little information about Math 2. There is a lot of more writing in Math 2 than I think there is in Math 1 and even Math 3, because Math 2 is more geometry based than the other ones. So what happens in geometry is you talk a lot about these shapes and these definitions, and then you have to apply them to other things later. So that's why you might see more things kind of happen. Does anybody have any questions about these three terms? Let's talk about how to name them as well. So when you name a point, you typically just use one letter. So this could be point A. When you name lines, you typically use two letters that are on that line. And it doesn't matter where the two letters are. So we could call this line BC. And when you name it later, you will put BC with a line over top of it. So that way you know what you're talking about. And when you name a plane, you typically use 3 or more letters. So the letters come from the points or the lines that are on there. So since a plane is made up of lines, which lines are made up of points, you typically just pick 3 points on the plane, and you would call this plane XYZ. So you actually draw the shape that it is and then write those letters down. So if you don't have enough room on your notebook or your index card, I would put these like designs on your notebook paper so that way you know what they look like and how to name them. If you already did it on your index card, that's fine too. But points, again, 1 letter. Lines are 2 letters. Planes are 3 letters. It's good to know how to name these because later on when we get into the more tougher geometry stuff and you see things with 2 letters or 3 letters, you're like, wait, what is that? But 2 letters always a line, 3 letters always a plane. Is it okay if I go to the next slide? Okay. So on the next one, I know this is kind of like a hard thing to draw, but if you want to try to draw this picture, you can. And then we're going to answer these questions. These 2 things here will go on your index cards. I need the highlighter button. So this term with your definition, and then this term with your definition. Those 2 can go on the same index card. Coplanar will go on the front. Collinear goes on the front, and then the rest of the words on the back. Now we have a couple of questions that we're going to answer here for these. Sorry. So your first one is name a line. So first off, how many lines do you see in this picture? 2. One is more horizontal and one is more vertical, right? So you only need 2 points on that line to name it. Doesn't matter if they're side by side or they're not side by side. So let's name that horizontal one. How would you name that one? RQ works, RS. You could even go backwards. You could say SQ, SR, or QR. Lots of different ways. It's still the same line. So I'm just going to say RS, and then you have to put the line over top of it. Okay? So you have to put that symbol. That way we know it's a line. You could also name lines by one lowercase letter. You see this little cursive? It's actually a cursive L. I know it looks like an E, but it's actually a cursive L over here. So you could also name that one line, line L. I have to typically write it in cursive when I start to write the word line. But you can name it line L. How could you name the vertical line? TN, yep, will work. What else? So you could say TN or you could say TQ. You could also say NQ or N. Or you could say line M because it's down here at the bottom. So naming the vertical line, you got several options. It's still the same line. Okay, how many letters do we use when it says name a plane? 3, okay? Any 3 dots that appear to be on that flat surface. So what 3 letters could you use? P, what else? You got name 3. V, one more. Plane, P, V. Now, the L is a cursive lowercase, so it's got to be a dot. Uppercase, not cursive. So P, V, or it can be on the line. R. PVR could work. So it's any 3 dots that are anywhere on that plane. So it looks like this line is resting on that plane, so any 3 letters could work. You can. I would probably just put that on your notebook paper. Now, if you drew the picture on your index card, you could add it to your index card if you wanted to. Now we have our new definition. Collinear are points that are on the same plane. So on the same line, sorry. So name 3 points that are on the same line. What 3 points would that be? RQS. RQS. Notice how I separated them because we're talking about points. You wouldn't write them all together. Point R, point Q, point S. Now we name 3 coplanar points. Those are points that are on the same plane, which would be P, V, R. P, V, and R work. Yeah, any of those that are on that same plane will work. So point P, point V, point R, all of those are on the plane. So that works. Yep. Good job. Any questions? Okay. Let's look at our next slide. We only got a few more to go, so a few more definitions maybe. All right, these 3 can be on the same index card as well. So we have 3 parts here. Segment, ray, opposite rays. I would put this design, you could put it either on the index card or your notebook paper. So this is kind of more like an example that you could put on your notebook paper, the line at the bottom. and we'll draw a picture of each of these after you write down your definitions. Sorry about all my coughing. Was anybody else sick over Christmas break? Yeah. I heard the flu was bad. I know a couple of my students got the flu during exam week. So a segment is part of a line. It has two endpoints. So it looks like a line, but instead of arrows, they end with dots. That would be a segment. Now, if you put a bunch of segments together, you could probably start to form a full line by itself, right? So in this picture, I see 3 different segments. Name one segment from this picture down here. Use just 2 letters. AB. AB is definitely a segment. It stops and ends. So if I wanted to name this as a segment, I would write AB and then just put a segment over top of it with no arrows. That means you are just focusing on that one part of the picture from here to here. It doesn't keep going. There's no extra arrows. Okay, array is part of a line with one endpoint. So array could have an endpoint on the left and then go to the right. It could have an endpoint on the right and then go to the left. However you name it, you draw it the same direction. So let's say that I wanted to name this ray. How would you name it? Well, you would start with the endpoint. What's the endpoint? B. And then you name any letter after that. You could say BC or you could say BD. Does it matter? No, it means the same thing. So when I name that ray, again, I could say BC. I have my endpoint and then I draw my arrow so I know where it goes. I could also name that ray as BD, endpoint, arrow. So make sure you show that you have an endpoint and then make sure you show an arrow. Now, opposite rays share the same endpoint, and when you put them together, you make a line. So if BD is one ray, the opposite ray would just be opposite from that. It would be BA. So we would say BD, oops, I keep wanting to put an arrow, and BA are opposite rays. They share the same endpoint, which is B. They go in opposite directions, and they form a line. All right, any questions? All right, we've got one last thing to talk about, and then I will tell you guys about your homework for tonight. Most of it is answering yes, no, sometimes true or false. So it's pretty quick. All right, on your index card, go ahead and put the word postulate on the front, and then your definition here on the back. Yeah, this is the only thing we're going to put on this index card. And then these 4 things put on your notebook paper. You don't have to draw those pictures if you don't want to. I know this one looks really confusing. If you want to draw the cube one, you can. But postulate is an accepted statement or fact. If you wanted to. Some of the examples I said you could put on there. But those 4 little bullets, you can write those on your notebook paper. I'm going to go ahead and talk about these while you guys are finished writing, because I realize we don't have a whole lot of class time left. But the first one says, through any 2 points, there is exactly 1 line. Think about what you did in Math 1 whenever you took it. When you were graphing y equals mx plus b, you plotted the y-intercept, and then you did your slope as rise over run. And then you can make a line. You only need 2 points to make a line. So that's why that first statement, that postulate, is a true fact. As long as you got 2 points, you can draw a line through it, you can grab your ruler, and you can have it extend and keep going. The second one says you need 3 points to make a plane, and that's how we name them too, right? 2 letters we can use for a line or a ray or a segment, but we need 3 letters when we talk about a plane. Now, when 2 lines intersect, where do they intersect at? Like this, at 1 point, right? It's where they kind of go together. So if you have 2 lines that you wanted to draw, they would intersect there at that point. Now, we're getting into some stuff later in Math 1. You talked about lines that are parallel, never intersect, and maybe they're perpendicular. They intersect at an exact point. When 2 planes intersect, they intersect to form a line. So these 2 pictures I kind of wanted to show you. The one here on the left, you have this kind of blue plane, and then you have the yellow plane. And where they come together, they form this line here. That's where they meet, is that line that they come together at. If you have a cube, or like I've been using a lot today, like a Kleenex box, The sides that come together, they hit on this line. So remember, planes are like your sides. They're your flat surfaces. So when two of them come together, they form a line. So if we're trying to name the line that they form, if you're talking about this plane on the right side, you can name it BFG, and the plane on the top, ABC. Where do they come together? They come together at line BC. Now, on this picture, does this look like a full line? No, but planes, if you remember from the very first definition, extend on forever in both directions. So this is going to extend on forever. So anytime you have two planes, they form a line. So make sure you put that line symbol above it. If you're done copying down this, open those Chromebooks back up. And we are going to talk about your homework for tonight. Now, homework always needs to be done on a separate sheet of paper. If you got extra index cards, save them for tomorrow. I couldn't remember how many we would need, so just save them. Now, the homework might start off a little bit confusing because the page number that I give you is the online book page number, but the physical page number is 40 pages less. Okay, so let me show you what that means. So if we're back here in our homework section, if you click the page number, it will take you to the online textbook. What I highly recommend that you do today during your free period or tomorrow during your free period is download the textbook. Okay? So you want to make sure that you download this textbook to your Chromebook so that way you can use it offline. Because what if something happens and your power goes out? Then you won't have your textbook to look at. So make sure that you download this textbook, okay? Make sure it also says geometry, because sometimes if you click this back button back here, it goes into a different page book. Yeah, this one does have 1,000 pages in it. If you check out the table of contents, it will show you all the stuff that we're doing, but also there's some interesting things down here at the bottom. Okay, so anyway, I have it downloaded here. I think it's starting to download again, but we don't need it to. But if you're downloading it, that's great, because if you download it, it now pops up like this, where you can just go at the top button here, and then you can type in tonight's page, which is page 56. Why did you put me a little crazy emoji there? And then it jumps straight to what problems that you have to do. So download it maybe during your free period, because it might take a while if we're all downloading at the same time. But you can go ahead and start on your homework. Now, what I recommend that you do on your notebook paper, make sure you put your name on it, and then at least put the page number on it. So if you need to know what problems to do, I write them up here on the board, but then they're also on Canvas. So only do the problems that I assign. Don't do all the ones on the page. Okay, and the page should look like this. Now, if you're looking at the page number on the book, see how the page number right here is 16? It's going to be 40 pages less than the page that I give you, because if you're looking at the online book, it's page 56. Does that make sense? All right, I will make it bigger up here too, so if your computer's going kind of slow, you can read up here and answer the questions. But again, separate sheet of paper, put your name on it, put the assignment on it, maybe even put the date on it. And you guys got about 10 minutes to work. Now, I always do the homework that I assign, and it didn't take up too much paper. As you can tell, the last few ones are just one-word answers. You just say coplanar, non-coplanar, always, sometimes, never. So they do go a lot faster than it looks.